Hi, and thank you for joining us today for this live streaming event in YouTube. Now, my name is Sylvia Choi, and I'm a science educator at Castro, which is the Center of Excellence for All-Sky Astrophysics. Now, here today we have Dr. Vanessa Moss talking to us about why study physics. Now, remember, if you have any questions or comments during the talk, please either send them to us by email or tweet to us live, and we'll actually put them on live on screen during the presentation. And the Twitter handle is #CITC16. Now, I'll join with you again at the end with some Q&A. But for now, I'll leave with you with Dr. Vanessa Moss.
Okay, so hi everyone. My name is Vanessa, and today I'm going to give you an idea of why I think you should study physics, and also frame it in terms of what I call exploring the universe. So firstly, who am I? I'm Vanessa. I'm an astrophysicist. So let's talk a little bit about what that means. So astrophysics is a little different to astronomy because we have the word physics in it. So if we ask Google, which is a good thing to generally do, then you see that it emphasizes the physics of bodies, not just looking at them, but what is really going on far away in galaxies, in other planetary systems, in stars. And so that's what astrophysics is. That's what separates it from astronomy. When I was a kid, I thought that astronomy and astrophysics was probably similar to some of the ideas that you have. So I dreamt of standing on one of the moons of Saturn and looking up at it filling the sky. I still think that would be a really cool thing to do. Or something like this other image here. I had a little meteorite that my parents bought me when I was at a science museum. I read books about science, about stars and how they worked. I learned about what stars were really made of from Pumbaa in The Lion King. And I also had my own telescope, which I was pretty proud to, show my parents and my friends Jupiter or Saturn through the telescope. So this is what I thought when I was a kid, but as I was growing up, I actually, for a long time, I wanted to be a writer. So I didn't start off thinking from the time I was 5 that I would be an astronomer. It's something that evolved over the course of my studies. So what does an astrophysicist study? What you see now are some of the different physical objects that I've studied in astronomy over time. So ranging from, in the top left, I guess, from your perspective, the top left is the Milky Way, so our home galaxy, and I studied that for my PhD. I've also studied supernova remnants, high velocity clouds in our halo, and also a supershell that looks like an ice cream cone if you flip it upside down, so you can see that now. Recently, what I'm studying is hydrogen in absorption towards some of the very distant galaxies that we can see with our telescopes. And so that's very exciting as well, and quite different to what I've studied in the past. And there's a lot of different things you can study as an astrophysicist. So what do we do in our everyday job, you're probably wondering. As I'm an observational astronomer, that means a big part of my job is using telescopes. And this is super exciting for me because I love data and I love seeing what the data can tell you and being the first person to really see what the telescope has collected from galaxies or planets or stars. So that's a big part of our job. If you're an observational astronomer, you get to use telescopes. These are some of the telescopes that you could potentially use, and some of them I've used either directly or I've used the data from them. There's a mix of different kinds of telescopes, which we'll come back to with the electromagnetic spectrum. But what you can see, there's optical telescopes, infrared telescopes, X-ray telescopes, and for me, because I'm a radio astronomer, there's also radio telescopes. Some of the other things you can do, you can also visit telescopes in person. I've been very lucky to do that. Obviously, if your telescope of choice is Hubble, that's a lot more difficult. But if there is a chance, it's a very good experience to learn exactly how the telescope works, how the engineers keep it functioning from day to day. So that's been a really valuable experience as part of being an astronomer. We also write papers, so that's the main way we can communicate what we do with other astronomers. So we want to be able to say, this is what I studied, these are my results, and also find out what their results are too. So writing papers is a huge part of communicating what you found. We chat to others, so people might not think there's a huge social aspect of it, but actually every day we're talking to our colleagues, we're emailing people overseas that we're working with, we go to conferences, we're constantly trying to keep up to date with what other people are working on and how that relates to what we're doing. So chatting to others is also a big part of our job. We present our results, so this is in a more formal way. So at a big conference, you might have a talk spot, in which case you'll have about 20 minutes, which is what I have today, to communicate, the point. What is your research? What's the big question? What are the results you want people to take away from it? So this is a photo of me at, I think it was the ASA, which is a big astronomy conference in Australia that takes place every year. So being able to put your results together in a nice presentation and communicate clearly is an important part of our job. We also have to read papers. So as well as producing papers, it's important to see what other people are writing. And that's really hard because there are thousands of papers in astronomy coming out every year. And so what you can see on the slide here is a tool that I wrote with a couple of other people to kind of make it easier to see what the results of a paper are. So it's called Archiver, you can check it out. But what it does is it really highlights the pictures of the paper. So what are the results? How are they related to the topic of the paper? One of the really fun things for me, and something I learned over the course of my undergrad, is that we develop code. So we use Python, well, I use Python, but everyone uses different kinds of languages, and we use that code and computers to really make our lives easier, to make things faster, to calculate and visualize data and understand what it's telling us. So the code that you can see at the moment is a Python code, and what it produces is this image here. So this is a picture of one of our nearest radio galaxies. It's called Centaurus A. The background with all the pretty stars is optical, and the white contours that you can see over the top, those are the radio jets that are kind of coming out from the supermassive black hole and pushing their way out of the galaxy. So being able to see that in the data using coding is a really important thing. But what you might not also know is that you can use code for things that are a little bit different. So what you see now is something that I've been spending a little bit of my spare time working on, making Zootopia licenses and train tickets and police badges for people that want them, so for fans. And so this is an unusual case of using code. Let me just see. So as of today, as of right now, the code has produced 2,399 licenses, 651 train tickets, and 243 police badges for people all around the world, that most of who I had never known before this. So it even made it to the Russian Facebook page, which is what you see at the right side of the screen, and also to Zootopia director Byron Howard's Twitter feed. So this is kind of, as well as doing coding for astronomy purposes, you can also work it into your life and do other cool things on the side. Outreach, so that kind of ties in a little bit. Outreach means we want to communicate why we think science and astronomy are important to as many people as possible, and everyone does this in a slightly different way. We all choose our own ways to do it. One of the things that I do is I work sometimes as a guide at Sydney Observatory, which is really fun, and it gives you the hands-on experience of talking to people who are enthusiastic about astronomy and science right in the moment. So what does exploring the universe mean? Because I've said that a couple of times. For me, it means having fun with the world around you, being curious, being interested in what you can learn every day, no matter what it is. It doesn't have to be, a picture of a planet. It can be anything that you encounter. So for me, sometimes it's looking at fireworks with diffraction gratings and trying to figure out what elements I'm seeing, or throwing chemicals into a fire. My brother did that, so that's why it's blue, and seeing what comes out, or going to Mars for the first time. So this is actually an education center in Victoria, not the real Mars. But that kind of thing. So just being interested. For me, it's very much science a lot of the time. How can we look at the world through scientific eyes and just basically have fun? For you, it will be different. So exploring the universe is kind of the more important thing that I want you to take away from this. So what are the ingredients for being a good explorer of the universe? You need to be curious. So you need to be curious about the world around you. You can't just be happy with everyday stuff. You need to want to learn more. You should have a sense of adventure, because everything's more fun if you have an adventure along the way. Investigative skills. So this is, not just taking things for granted, figuring out, what is the evidence that I see telling me? What is it really, how does it piece together to solve the puzzle? You should be good at keeping records. That's important, being organized and keeping track of what you've done. You need to be able to see the big picture as well. So not just the fine detail of what you might be studying on a given day, but also how does it relate to the bigger picture of what people are doing in general. You should be critical, because you need to be able to look at your work and say, does this make sense? Constantly ask yourself, does this all fit together in the way I expect? and have a desire to ask questions, which is arguably one of the most important things. As long as you keep asking questions, then you'll never be satisfied with the status quo. You want to be able to look forward, like, beyond that. Things you'll probably need if you realistically want to be a physicist or an astronomer, you probably need to finish high school. The reason I say probably is because this isn't true of everyone. It depends, it varies a little bit on your specific path, but the majority of cases, you need to finish high school. You'll need to do an undergraduate degree that involves science, probably physics if you want to be a physicist. You do need to do math, and so this is a question that comes up a lot, you know, math is hard and I really love the physics, but I don't love the math as much. And so it's a tool. You need to see it as something that helps you understand the world better. But you can do math at lots of different levels. You don't have to just follow a specific path in math. Coding, so like I said, coding is a really big part of what we do now. And also being familiar with the latest technologies. So, you know, this sounds silly, but like the newest phones, the newest computers, being able to, virtual reality is a big thing now. Being able to get on top of those and be familiar with those will help you in your role as an astronomer to see how you can do things better. And you also have to be willing to fail, which probably sounds a bit weird, but you have to understand that to really get to the end, to be successful, to figure out something new that no one else has ever figured out before, you're going to hit some road bumps along the way. So you need to be prepared for failing sometimes, which is hard, but it is part of what we do. So what path did I take? So I completed my HSC a long time ago by your standards. I found this, so I guess I can show it. So these are the subjects I did, in case anyone's wondering. This came from my mum's bathroom where I had stuck it up back in 2004, and apparently it was still there, so I brought it today. So those are the subjects. I did a range of things. I didn't just focus on one. I did all the things that I was interested in, and I had a lot of really great high school teachers too. At university, I still wasn't entirely sure what I wanted to do, so I did a Bachelor of Liberal Studies, which is kind of like arts and science. I majored in physics and Japanese. This included a semester overseas in Tokyo, where I practiced more Japanese and studied. Then I transitioned into a PhD in physics, which was also, as well as being here at the University of Sydney, it was in collaboration with CSIRO. And during that time, I started working at Sydney Observatory as a guide as well. So that's kind of my quick background. These photos that you can see, so the big photo is the official conference photo of one of the astronomy conferences I went to near the end of my PhD. And it was just so much fun. It was a lot of people getting together and thinking about how we do astronomy, not just what we do. So can we do it better? Can we do it with cool new technologies, especially web technologies? And in that photo, the camera was falling off the table, which is why everyone looks so horrified. The other smaller photo of the group of people, that was my dorm in Japan. So these were the people that I spent my 5-6 months with. And that was really fun. And also the bottom picture is my first scientific research poster. So that I was pretty proud of that. So let's come to an important question, which I get asked a lot. Well, why study physics, but also framing it as why not study physics? What are the reservations that you might have that are stopping you from taking up physics at a higher level? And so these are some of the common reasons. They're not all of them, but these are some of the reasons that you hear a lot. So, you know, you need to be really smart, only really geeky people do it, it's really boring, what use is it? You know, I could go and be a doctor and save people's lives, or, you know, physics can't take you anywhere, like, you know, I'll just be stuck doing boring science in a lab. So the important thing about these physicophobia reasons is that they're all wrong. And so I'm just going to focus on the 3 bottom ones for time and go into a little bit more detail about why they're wrong. So in high school, the focus, and in university as well, the focus is on teaching you the basics. Before you can construct a model of a black hole or understand the details of nanoparticles, you need to understand the kind of very basic stuff. How does a ball roll down a hill? How does a pulley pull a mass up? Because with those basics, you can then expand them. So that's why the focus in, you know, in high school and undergraduate physics is the more simple things. It's not all the really exotic physics, because you need those fundamentals to be able to move on to the exotic stuff. And I agree with you, wedges and pulleys can be pretty boring. Some people really like them, but I found them boring. So you really have to see it as we're focusing on the fundamentals at the lower levels so that you're best prepared to do the really cool stuff once you're on top of all of that. And truthfully, year 11 and 12 physics have a lot of really cool topics. For example, light. So we're not just talking about visible light, which is what you see on this slide, but the whole electromagnetic spectrum. As a radio astronomer, obviously radio waves are pretty important to me, but it's also important to know that every part of that spectrum is telling you something different physically. Radio light is produced in a different way to optical light. So if you can understand what physical processes are making these things, you have a better understanding of the universe. Cloud chambers, so these are so cool. These are really fun. By supercooling the air and having all that moisture in there, you can see particles, ionized particles that you wouldn't usually be able to see, and you can see their paths and really understand that there's a subatomic world way below what we're used to thinking about. We're used to this macroscopic world where we can pick up books and sit on chairs, but there's so much going on beyond the limits of what we can see and interact with. So that's really cool too. And magnetic fields. So magnetic fields are always interesting. In the context of astronomy, magnetic fields are becoming more and more a part of the things that we have to think about, because it's not just simple physics sometimes. When you have magnetic fields involved, things get complicated. And we know that our Milky Way galaxy has a huge magnetic field, and so there's a lot of questions about how that magnetic field influences. It's a large scale thing. How does it influence things on our scale? So a lot of people are studying that as well. And of course, very tied to astronomy is the Big Bang. So there's so many aspects of cosmology, how the universe began and how we got to where we are today, and what happened along the way. We have a lot of questions remaining, as much as we've been able to figure out so far, the most recent thing being gravitational waves, and also the fact that the universe is expanding faster and faster. We're still trying to piece together a lot of the puzzle pieces to really figure out how we got to where we are today. So what is dark matter, and where did dark energy come from? How do these things drive our universe? And those are still really big questions for astronomers, not just anyone studying the Big Bang. So another aspect of this is, what use is physics? What has it done for you? How has it improved your life? And realistically, while there's a step from physics research into the technology that changes our lives, if we didn't have the physics research in the first place, we would live in a very different world. So to give you an example of some of the things that physics has contributed to, so we have our planet. We wouldn't be in space if it wasn't for physics. We wouldn't have the ISS. We wouldn't have rockets. We wouldn't be able to do all the really cool things we've done in space science without understanding the physics behind it. And then I'm just going to show you some of the different things which you probably are aware of, maybe some you don't know for sure. Cameras, phones, fiber optics, MRIs, X-rays, rockets I already said, there's the Parkes telescope, GPS. So when you use Google Maps to figure out where you're going today, that relies on general relativity. So the time delays between satellites, because they're moving so fast around the Earth, create an effect that means that if we didn't take that into account, you wouldn't have the accuracy that we do. TVs, CERN, Angry Birds, I don't know why I put that in there. Phone games, I guess, physics of birds. And the Hubble Deep Field. And the thing that all of these things have in common is physics. So it's a really fundamental part of what we really like about our lives today. And I included this quote because, so Maria Mitchell was an astronomer that lived in the 1840s, and she said, the more that we see, the more we're capable of seeing. And I think this really highlights why physics research and physics is so important. Until we understand more about the world, this is from the quantum level up to the galaxy scale, unless we understand that, we don't even know what's possible. So we need to keep exploring that and keep figuring out what's going on so that we can truly figure out all the cool things that we can do in the future. All right, so the last thing is, physics can't take you anywhere, not even to a job. So firstly, that's not true. Travel, if you like traveling around the world, then becoming a physicist or an academic researcher is a really huge part of what we do, because we work with collaborators overseas, we go and visit them, we go to conferences, we travel and kind of advertise the work we're doing as well. So it is a necessary part of being an astronomer and being a researcher. So during my PhD, and the list that you see on the slide is increasing distance, so obviously Wentworth Falls isn't very far from Sydney, but I also went to Melbourne, Perth, Narrabri, Hamilton Island, New York, Boston, and Greenbank as part of my PhD. As part of my postdoc so far, I've been to the Netherlands, to Germany, to the US, and to Canada to both work with people and take part in conferences. So if you really like travel, then it's a great thing to do, because you get to travel a lot. tiringly so sometimes. So we can also look at what my friends did, right? Because I became an astronomer, but what else did people that I did undergraduate physics become? So what you can see here is a photo from our second year of uni. And it's what you're going to see in the terms of their jobs is very up to date, because I Facebooked everyone last night at the last minute and was like, is this still true? Okay, so let's have a look. So we have a developer at NICTA, which I think is possibly now Data 61, so developing cool software and hardware solutions. Engineering lecturer here at the University of Sydney. Pharmacology postdoc. Structural engineer. Embedded analyst, so this is more of the kind of data science side of things. We have a primary teacher, a general service officer in the army, a high school math teacher, a doctor, a solicitor who's now overseas in England, a clinical program associate, which is working with a medical company, and me, who's an astrophysics researcher. And so, as you can see, I don't think none of us have become the same thing. We've all done very different jobs and very different careers, and everyone's having a lot of fun doing the different things that their physics background has led them to, and their science background as well. So let's look a little bit more at what kind of things they do. So Mike pointed out that as a high school maths teacher, you guys probably have a pretty good idea of what he does. So instead, I thought I'd just show you a couple of slides from some of the things he does with his students. So the reason it's important is with math, we can take these tools that have developed and try to solve real life problems. So if a farmer has 18 meters of fencing, how does he build the best pen possible? And so you can frame that in terms of a math question, which is what Mike has done here, and come to a solution and figure out what is the optimal thing. How do we maximize the usage of the fencing we have available? And so that's one of the really powerful things of math. And his role is to take what he learned in physics and maths and science and try to communicate that to the next generation of physicists and mathematicians, which I think is really cool. So Aaron's a solicitor. He told me his official job is senior associate, which apparently means he's old. I don't know what that means, but he works with scientists and engineers, so technical people, about inventions or innovations that have come out, and tries to figure out should they be patentable or not. And he presents that to the court. So at the moment, he is in the UK, working for the same firm he does in Australia, and doing similar things. So that sounds really cool. And he obviously is using his physics background to make good choices about patents. Leo is a clinical program associate. We tried to come up with what that is in short terms, but it seems to not have a analogy. But what it is she works as part of a company. Their specific focus is ultrasound technology, and what they're trying to do is come up with ways of preventing infection. So she said one of the really cool things about her job is that she gets to do lots of different things. Sometimes she's a scientist using that technical background to plan clinical studies. Sometimes she's a business person, a market researcher, trying to figure out the best way for the company to invest in new technologies. And so she really enjoys that diversity that she gets to do, and also helping people. So Benji is a lecturer. He's in engineering, and what his particular focus is on landslides. Obviously, landslides are a natural disaster and they kill lots of people. The thing that he said sets landslides apart is that they're killing more people every year. So a lot of natural disasters are decreasing in their impact, landslides are increasing. So it's important to understand why. And he also wanted to point out that he gets to go skiing for work, researching snow avalanches. So Phil is an engineer. He's a structural engineer, and he described his job as making sure that buildings don't fall down, which is pretty important. He came up with this description, so people can't lift buildings. Can you lift a building, really? I don't think it's about commitment to the gym, but that's what he likened it to. But as part of his job, he gets to work with a lot of different kinds of buildings and contribute to making them as cool and as safe as possible. So recently he's worked with the Sydney Opera House, Parramatta Primary School, the new design for that, and this photo is him at Vivid making sure it didn't blow away. So in conclusion, for the kind of bulk of my talk now, we're going to go into question time, is that I think if you like science, you should definitely consider taking year 11 and 12 physics. There's never going to be a better time to kind of go that path. You can come back later, but it's really hard. So if you have this inkling that you want to be part of science and you want to do physics, then now is a really good time to do it. Math is going to be part of your life, but it doesn't have to be a bad part of your life. Math is really cool too. it can be hard, but because sometimes the math you do, likening it to the real world, is challenging, right? We can do really pure mathematics that seems very distant from reality, but really it's just a tool for understanding the world around us. So if you see it that way, it's not that different to physics, and it's really important as well. So a background in physics, you might not have known, but it can lead you to a lot of different opportunities. It's not just a scientist, you're not just in a lab coat over a Petri dish. There's a lot of different opportunities open to you depending on your interest, and with that physics background, doors really open. So you can go into a wide variety of things, you can travel around the world and do a lot of really fun stuff along the way. So if you are interested in science, do physics, because I really like that little sign thing. But also what's really important is that obviously not all of you are going to become scientists. That's realistic. But hopefully you have an appreciation of science. If you can do physics, then you can have that as part of your tools of looking at the world around you, looking at it critically and logically, but also just follow your passion. So follow your curiosity. Don't think that like the decisions you make now define the rest of your life. It wasn't until year 12 that I thought, maybe I could be a physicist one day, but even then it wasn't set. So just do what you're interested in, I think, is the most important part, and that will be the best choices that you can make. And that's it. Thank you. And telescopes, they're pretty cool. Good part of being an astronomer.
All right, thank you so much, Nessa. Now, there are a few questions they've been asking on Twitter. There's been quite a lot, actually. I'm trying to go through it all and choose a few things. So you've answered a few of the questions as well that they were streaming through, so I'm just going to choose some of the things that may have not been covered in the talk. So this is, I think, quite a lot of students, like students from Mary McKillop College and Maya Caniff and Sarah and Gabby, have asked you who and what actually encouraged you or inspired you to become an astrophysicist.
Yeah, so that's a really good question, and thank you guys for asking that question. So like I said, I wanted to be an author. I really liked writing. I was going to write children's books. When I was in year 11 and 12, I had a really great physics teacher, Mr. Mani, and he made the subject fun and interesting. So that played a huge role in deciding to do physics at the university level. At that point, I decided I was going to do kind of a mixed arts and science because I still enjoyed both of them. And then when I got to university, I met a couple of astronomers who I still work with now, Tara Murphy and Anne Green. And they were so enthusiastic about astronomy and so keen to kind of share their knowledge with students and kind of encourage us that it really had a big influence on deciding to do physics at a higher level.
That's really good, actually. They're very inspirational people.
They are.
Yeah. Now, I think you sort of talked about this in your talk, but just going a little bit further, what are some of the benefits about studying science and astrophysics, like some of the benefits you can get from it?
I mean, yeah, so some of the things I covered, the benefits I think are, so one of the things we talk about a lot as astronomers and educators in science is we want the world, but Australia as well, to be as science literate as possible. What that means is, being able to look at its problem solving. It's, looking at a problem and saying, this is the evidence I have, this is what it tells me, not coming in with a particular prejudice or a bias, but actually basing your interpretation on what the evidence is. So I think that's a huge part because that's not just applicable to science, it's applicable to your daily life.
Yeah.
When you look at the world around you, when you choose to buy that dress over that dress because of the different savings, or if you go to the grocery store and you're trying to figure out is a good deal or not, it's always just looking at the world from an interpretive perspective and just applying that science. So I think that's probably the biggest thing that comes out of it, and it's not specifically science, but also, yeah, like I said, it does open opportunities. You don't have to be a scientist by studying physics or science, but it does give you those skills and the tools you need to be successful in whatever you do.
Okay, awesome, yeah. So it does give you a lot of tools, but also it gives you that skills, right?
Yep.
Yeah, and critical thinking skills.
Yeah,
of course, yeah. Now, there are a few ones, actually several ones mentioning astrology. And how is astrology linked to physics? So there are a few of them actually out there, so I thought you might want to just give a bit of clarification perhaps.
Okay, so Sometimes, like, I do, you know, I say I'm an astronomer, and they're like, oh my gosh, I'm like a Scorpio. What does that mean? It means very little. So astrology is a pseudoscience. If you don't know that word, that's a good research topic for you. Astronomy is a scientific study where you try to understand specifically the cosmos in a scientific way. Astrophysics is with that framework of physics. Astrology likens, you know, the movement of stars and planets to our daily lives, which is a nice thought. It'd be cool if we could know all the answers to our lives based on where Jupiter is in relation to Mars. But realistically, I think going back to that evidence thing, if you know, you need to be able to look at it and say, like, what is the likelihood of me being born in the month of October? What does that have to do with who I become? And I think it's important to see the difference between those things. They're kind of fun, like, you know, people want to know the answers to the unknown, but they're not science.
No. Okay, I'm glad you clarified that. Because it quite often there is actually quite a misconception that astronomy and astrology is related, but
not related.
There really isn't.
Nope.
Yeah. Okay. So this is a really nice question by Miley, I think. So what's the most interesting that you've ever learned as an
Whoa, that's hard.
We can get back to that if you like.
No, let me think. The most interesting thing I've ever learned. Oh, okay, let's come back to that. To think about.
There was something similar as well.
Yeah.
There's a question from Ruby Tilly. Is there another Earth, and do you believe in extraterrestrial life?
That's a good question too. So is there another Earth? I mean, that's a specific, if you're saying is there a parallel Earth, then the answer to that I'd say is no. If we're saying instead, are there planets out there that are like Earth, that are habitable, that possibly have life of some form, then I would say yes. More and more from the studies that we're seeing from telescopes and satellites like Kepler that are looking for planets around other stars is that planets around stars are super common, and even Earth-size and Earth-like planets are becoming increasingly common. And so I don't know much about it, but recently, like today maybe, they released a press release saying that they'd found some more Earth-like planets around a star.
Yeah.
And so if you take into account how many stars there are in our galaxy alone, and you know the conditions of that produce life, you know, they're not that constraining, then I think it's likely that there's life out there. There's a lot of problems with, you know, for example, the light distance between us and other stars. We're not going to like call up the aliens and talk to them. And also life develops in different ways. So, you know, if life was on a planet on the other side of our galaxy, would it look anything like us? Would it broadcast in radio waves? Would it communicate in the ways we think it would? And so there's projects at the moment like Breakthrough Listen and Breakthrough Starshot, which are really trying to get at this question. So Breakthrough Listen involves some Australian telescopes.
Yep.
And what they're going to do is do a systematic search supported by Yuri Milner and other people to try and figure out, can we find life near to us in our galaxy? And if you think about how many galaxies there are, it'd be crazy for us to be the only ones.
Yeah, universe is actually really huge, so that really makes sense that it does if you think about it in terms of just numbers. Alright, so this isn't, so I think you've mentioned this before, but just again, if you weren't an astrophysicist, then what other career path would you have been doing? Just out of curiosity.
That's a good question.
Yeah,
I mean, if we're being honest, I still don't know what I want to be because it's still kind of a work in progress.
Yeah.
I mean, a writer would have been fun.
Because you said about picture book?
Children's books.
Children's books,
I had it all planned out. There's going to be a 10-book series.
Never know, you might be doing that later in your life.
Maybe. But I think because for me, what's really exciting about what we do as astronomers is being paid to be curious about the world and explore data. I really like data and playing with it and seeing what it can tell you. So I'd probably be in something similarly kind of technical and technological that involved trying to see what the world around us is telling us, the kind of data. But I wanted to be a paleontologist. I wanted to be an actor for about half a year. That's
awesome.
I know. I was like, and then I realized I couldn't act, so that was a bad idea.
It's actually quite a hard thing to do, acting.
Yeah, it is. Isn't it?
In front of camera particularly.
And Japanese, right? So
Yeah.
one of my other majors was Japanese.
yeah.
So for a long time, I used to tell people that I would be a physicist in Japan because that was the logical extension of what my undergrad had been.
Sure, yeah.
But you know, you never know.
Well, you never know, you might actually go there after all
Yeah.
and polish up your Japanese a little bit. So there's also quite a questions about, lots about space travel.
Okay.
The one thing I do, like, I guess one of the questions asked by, again, Gabriel and Sarah, but also Callum Wood as well, is first of all, you know, if you had a chance, would you travel into space?
Yes. So I think it'd be really cool. I think at the moment it's very difficult to be an astronaut because it's so competitive and it's really not a part of our lives yet. I'd like to see it become that.
Yeah.
So we obviously...
So that was actually linked to Callum. Callum said, do you see Australia either joining the European Space Agency or working on our own space program in the future? So that was sort of linked as well.
Yeah. So obviously we don't have much of a space industry at the moment, but we do have a lot of people working to make that happen.
Yeah.
So we have people doing cube satellites and also just promoting the space industry, hot air balloon telescopes and things like that. So there is a lot of potential for Australia to grow in this area. I went to a talk recently which was really cool. It was like opal treasure hunting combined with space, and what it was it was a geologist who was studying opals and kind of the geology of where opals are, why are they so common in Australia. He's based here at the University of Sydney.
Yeah.
And what he found was actually that it was to do with the conditions. So we had this big lake that came into Australia, we had geological conditions that matched that, but what he likened it to was Mars. So actually Mars has similar geological conditions to Australia.
Interesting.
So in some ways, the center of the Australian desert is very similar to Mars terrain. So that's kind of cool. We should utilize that. But if I could space travel, like I said at the start of my talk, I would go to Saturn's moon, probably Mimas, which is one of the closest in ones, because I think it would be so cool to be able to stand there and just see Saturn, right?
Yeah.
Like in the sky, like
Yeah.
that would just be crazy.
Yeah.
And if I could do that, you know, in a reasonable time frame and then come back to Earth, that would also be convenient.
So Mars one is not an option for you at all, is it? Like just colonizing somewhere.
Yeah, I don't know. I kind of don't like the color red enough.
Oh, okay.
Or I like oxygen a lot too.
Oh, right.
But there are lots of people that are really excited about the prospect of going to Mars, so I think that'll be exciting.
It
And
would be.
hopefully it will happen in the next 20 to 30 years.
Yeah, it's getting closer, my understanding is. And there's one question from Stephen. Being an astrophysicist, do you think you'll ever head into outer space to conduct more in-depth research?
Right, yeah, so that is a possibility. So in terms of if people are thinking about pathways to becoming an astronaut, you can, obviously there's been the military pathway, which has been the majority for a long time, so having the training in the Air Force or the Navy.
Yeah.
It's mostly Air Force, isn't it?
It's Air Force, yeah.
So if you have that background, but also they do need scientists up there. They need people to, you know, for example, on the ISS, they send scientists up there to conduct the research experiments. So I think, yes, there is a lot of potential. If you're interested in being an astronaut, then having the physics or engineering background will really help, because you can also, as well as having that, you can frame it, you can do extra things that make you more, like, what's the word, not competitive, but more applicable, to, you know, like more suited to be
relevant,
an astronaut, right? So you can kind of build that around. But even then, it is really competitive, although that could change hopefully in the next 20 years as we have more.
Space programs are just coming up from different countries now, so
and
it's not just
as well.
Exactly, privatized companies. So it's not just NASA anymore; it's everywhere else as well. So it's we can only hope, right?
Yeah, that'd be cool.
It's very exciting times actually that we live in. There is, so going back to that question again about what's the most exciting thing, or the you know, that you've learned, or you know, that you've encountered as an astrophysicist.
That was so hard. Oh my god.
So both Sophie and
just exciting things.
Yeah.
Oh my gosh, there's so many fun,
Miley
exciting
asked
things.
The question. Just one thing that you can think of out of the blue, just your head.
Okay, I mean, obviously one thing that is very cool is the fairly recent discovery of gravitational waves.
Yes.
And the reason that's so cool is because it took 100 years for our technology to catch up to the level where a prediction made could be verified. And obviously science sometimes happens serendipitously. We explore the world around us and we, you know, find out cool things like penicillin along the way. But sometimes, you know, there are really clever people who can take this physical model and say, look, I predict this will happen. And Einstein was one of those people, and he was able to say, look, gravitational waves should exist. It's very hard to detect them, but one day people might. And I think maybe he kind of gave up on it. I'm not sure if he ever thought it was going to be technically feasible.
Yeah, that's true.
So I think the fact that they were able to do this super hard experiment and actually prove that two black holes had smashed together so far away, that is very exciting and very cool.
Yeah, it is probably the most important discoveries I've made this year, if not the century.
Oh yeah,
so.
it's huge.
Yeah, it's huge. The Nobel Prize, most likely. Now, we got one last question, and I chose it as a very befitting one by Mary. What is one thing that you would like to say to young people who love science but aren't confident enough to study physics in their future?
Okay, so I'll look at the camera because you guys have asked that question. So if you love science and you want to do physics, then do it. Don't let anyone who says you can't do it or any results that you have that make you think you can't do it stop you. If you really want something, then just keep going. A lot of it is practice. Like I said, it's learning how to fail and be okay with that and take that failure and learn for the next time. So if you really do love science, then go for it. And whatever, like I said, whatever your passion is, whatever your curiosity, just follow that, and I think it'll be a pretty cool outcome.
All right, thank you so much for your talk.
Thank you guys for tuning in.
Thank you.